Hey everybody, welcome back. So this week we're going to be doing part 4 of our terrain particle system tutorial series. This is going to be the last of these tutorials where we're going to be bringing everything together into what is going to be a interactive project with several different modes and some pretty cool visuals using all of the work that we've done over the last several sessions. So let's jump into things. So we're starting here now is where we left off the terrain particle part 3 tutorial. So this comp is exactly the same as where we left off. If you guys haven't followed along through those tutorials, I recommend you do so before completing this one. And if you prefer, all of this as well as the project file and the component is available on my Patreon if you prefer to simply grab it there. Alright, so let's jump in here. So to give a high level, what we're going to be doing today, we're going to be adding a couple different inputs. We're going to be tweaking our velocity field generation. There's going to be a few just tweaks and improvements that we're going to go through to polish things off. I'm going to then jump back up here, go through how to easily connect a Kinect sensor, to drive this interactively using motion tracking, but you will also be able to use that technique for any type of input you like. Alright, so let's jump into things. I'm going to leave all of this as is since we built it all in prior tutorials and just start making some changes. So, first things first, I want to take my point file in and create a different input, or a couple different inputs. Actually, before we do that, let's just take a look at what we've gotten so far as far as inputs go. So right now we're on input 1, let's go to input 0. Now input 0 is going to be our normal map from the EXR file. Now we can see that this is looking a little bit funky, so let's make a note. We'll jump into that and figure out what's going on there. So that's our input 0. Input 1 is the slope that we calculated from the EXR height map. This one's looking pretty good, and so that's nice. Not much to do there. And then input number 2, or sorry, input index 2, input number 3, is the procedural height map that we generated using GLSL in the very first one of these series tutorials. So this one's also looking pretty good, and of course we can then put things in the middle to capture some behavior of both. So we have, let's say, 2 good velocity maps that are generating effects we like. Let's fix the normal map and then create another one or 2. So I'm actually going to open parent parameters. Just keep these over here. Put my velocity input index is 0, so now we're grabbing our normal map. And the reason that it's all going in one direction is simply because the normal maps, if we take a look by turning on our viewer, zooming in, and then hitting D on our keyboard, we can see in the lower left-hand corner here that our values are ranging from 0 to 1 for the most part. Our blue value is a little bit higher in some cases, but that is not really important to us because that is the perturbation of the z direction, which is inconsequential to us in our xy velocity velocity map world. So, what that means is all we have to do is use a math top, and just make our range from -1 to 1. And as we can see, now we're getting the effects that we desire, and things are looking a lot cooler already. Now, it is worth noting that you can definitely take some creative liberty here. For example, just something like a reorder top, flipping channels around can lead to some interesting effects. So here I'm just flipping the red and green channels. You could also, of course, use the blue channels, which, because it's essentially double the magnitude of the other two channels, is going to result in a directional motion like this, but it's kind of cool, depending on what effect you're going for. I do really like this, flipping the red and the green channels. And actually, so if we flip the red and the green channels, and then we use a channel mix to negate one of them, let's do the new green channel, and then make sure we're using 32-bit float here, and oops, red and green channels. Oops. About that, I believe. I think that's why. So then, because we're making our red negative, we actually want to go from -1 to 0 to -1, and then on green from -1 to 1. Alright, so what are we doing now? Here, what we're doing here is so yeah, here, let's take a quick look. So we have our surface, right? And we have our surface normal. And that's a right angle. And then what we're doing when we are reordering and taking the channel mix, and maybe it'll be easier if we look at something on a 3D plane. So if we have this point, and at this point we have a normal going out, it's going to say has an X and a Y component. What we're doing with the reorder is flipping the X and the Y, making this instead YX, obviously, and then we're multiplying the new Y by -1, so further, that's going to -Y X, where this is our normal. And what that means is that we are taking a perpendicular vector to our normal, which is actually going to be a tangent vector to our surface at that point. Now, that may seem pretty similar to our slope, since the slope is simply a gradient at any given point, and that would be true, is technically true, but the calculations are a little bit different, and the way that the slope top is calculating the gradient is different from taking the perpendicular vector to a normal, so it'll result in different effects. I think they're both pretty cool, and of course if we can always just go back and throw a normal math top in here, make this back to just -1 to 1, see that this still works, and so maybe what we want to do is just add our perpendicular vectors as another input. So what I'll do is select, grab this normal, wire that into the reorder, drag all of these down here, call this perp vectors, and wire that into our switch. Alright, so yes, just to reiterate, now we're looking at input 0, which is our tweaked normal map. That's just rearranging that from 0 to 1 to negative 1 to 1. We can then look at input 1, which is our original slope. And then we can look at input 3, which is the perpendicular vectors to the normal that we just created. Which again is similar to slope, but slightly different in the actual numerical output. So it's resulting in a different dynamic here. And then 2 is of course just our procedural terrain map, which nothing has changed on. So now we have one more input as well as fixing our normals, which is great. So one thing that I generally like to do is comment things as I'm going, especially when I'm doing some stuff like this. So if you do Shift-C, that'll create a comment box, and we can just make something simple like normal vectors to perp vectors. Yeah, simple. Alright, cool. So one of the other inputs that I want to add is using our point file on top. So I'm just going to copy and paste that, drag it down here, and take a look at it. So last time we used just our height in all of our channels. I'm actually going to tweak that, and we are going to grab flow instead. So I'm going to put flow, just flow, in the red column, and then RGB flow directions in the rest of the values, and then we'll take a look. So as a reminder, what we're seeing in this view is normalized for each of the different layers. Because we have our overall flow in the red channel, that means that this is a number that's representative of the overall amount of flow, not direction, and then the direction is represented in each of these other 3 channels. So let's just wire this right in and see what happens. Wire it in, move to input 4 now, and I'm going to hit 1 just to reset us. So, a couple things that we'll notice. 1, we are getting some cool flowy direction, but obviously there's all of these just dead zones in the middle that is being caused by lack of value for direction in our velocity map, and it's resulting in these pretty rough looking alias artifacts. You could potentially keep them or work with them in a artistic fashion if you like, but I'm going to show you how to remove them, and you can then decide whether you prefer to do that or not. So the way that we're going to remove them is by creating a simple mask and then just swapping out whatever values for the mask are, create a mask, that mask is going to have values based on the magnitude of flow direction. And then we'll take those mask values and use them to essentially just kind of blur out these black values. So to start, I'm just going to grab a null, a matte. This matte is going to be how we actually use something to overwrite, which I'll show you in a second. I'm just going to grab a regular noise, make it 32-bit float, 1024 by 1024, monochrome, and a period of, that's actually fine. That's going to go in our second input, and this we'll call our default map. This is our flow unfiltered. And then last we need a matte. And so, a matte. So what a matte top does, for those that are unfamiliar, we'll see if we can just drop a rectangle down, is surface pixels from one input or the other by using the third input. So matte channel alpha means that the alpha channel of our third input is going to be what determines whether the pixel in the resulting output of the matte top is taken from either input 1 or input 2. Pretty straightforward, very powerful. I use this all the time in a lot of different contexts. So what we need to do then, to get this to doing what we want, is simply say I want the matte top to grab all the pixels from the flow field unless those pixels are going to result in one of these black areas, in which case I want to grab from the default map. Because the matte top has that functionality very inbuilt by using this third matte, it means all we need to do is find a way to produce a mask texture that's going to be white where these holes are and empty or null the rest of the places. So again, if we jump in here and hit D to take a look at our values, oops, jump in here, hit D, we can see, and I hope you guys can see this too, we can see that there are some areas, and these are the black areas, where there are no values. Now we don't want to use the blue or the alpha because those can be generated, or sorry, impacted by, we don't want to use blue or alpha because we're not using those channels in our velocity map. So what we're going to do is just use a simple GLSL top to try and calculate the magnitude of the X and Y or R and G directions. And we'll just say if that magnitude is less than a very small number, we'll call that pixel white. So middle mouse click, GLSL, that produces a connected operator that does not connect to any other outputs. We'll edit this. I'll bring my VS Code over, zoom in. Alright, so we want the color to be taken from here, but we'll actually just call this sample. And then we do want our color to be sample.rg, or actually length sample.rg less than 0.001. That's just going to be my epsilon question mark. So now we're using a ternary expression. So what's going on here is, this is really like an if-else statement. So we're saying if this expression evaluates to true, then we do this thing, and if not, colon, we do this other thing. So what this is saying is color is going to equal a vec4 of 1 if the length of sample.rg is less than 0.001, and i.e. there is no velocity from the flow map, we'll have a white pixel, and if not, we'll have a empty pixel, which is exactly what we needed. So let's take a look. Seems like we have an error. Let's see what the error is. Expected sample. Okay, let's try this. And okay, cool. So sample may have been a reserved word. Alright, so now we have our mat. Pipe that in here instead. That's not exactly what we want. We want our mat channel to be luminance. And then we want to switch our inputs. And so this, if we pipe it into here, should give us a nice, smooth velocity map that's going to pull from our flow field, where we have flow field information, and is going to pull from our noise map, where we don't. And that's nice because it results in a nice, smooth velocity field that will not cause any clipping or alias. So, I guess worth noting, you could very easily do something like a select for this, and then instead of using a random noise, you could use normals. You could use any other maps that we have here. You could also very easily have this select be another interactive function or parameter, you know, with a switch or whatever else. So you can really have an endless combination of different secondary textures that are filling in for the gaps in our flow. And one of the ways that I generally find helpful to think about kind of designing interaction and parameters is viewing multiple hierarchies of parameter changes, I guess. So for example, if we're changing our switch as a primary driver of our effect, which makes sense given how much that velocity field changes things, those are very big changes. If we want some smaller changes, it's nice to know that when we are on velocity input index 4, we can do something like just change the select, and that will give us a cool change to our visual, but it's way more subtle, right? Way more subtle than just fully changing to a completely different velocity map. So something good to keep in mind. And I will leave it as normals for now, because I like that. So Control D to get my viewport clear. And I'm just going to collapse all of this to a base. We'll call this process flow. Shift C. This will be flow field with smoothing mask. Input index 4. Cool. And then just for good order, fix all of this. Text 2. Slope from EXR height map. Input index 1, and then finally, oops, this is slope from EXR height map, and then this is normal vectors from EXR height map. Alright, cool. So that's helpful. Let's maybe just clean this up a little bit. Select this, actually select the transformed point file in, and then let me give that to that null. Another select, yeah, so I generally try to use these select tops as much as possible. I like having kind of my different sections of the network broken up, and I find that select top versus connections make that delineation a little bit more clear. One other thing that we want to make sure we do is actually use the transformed, or copy this transform and pipe that into our flow field so that we are transforming our flow field along with everything else. And then just to be clean, we'll call this height map EXR, and finally point that. Cool. And then we'll say select normals. And cool. Good enough for now. Alright, so we've got the switch. Now we've got 5 total inputs. It's looking pretty good. For those on my Patreon, or sorry, for those of my premium Patreon subscribers, you can also throw the caustics input here as well. Obviously, replace any of these, add any of your own. Let's get our visual back here. Things are looking pretty nice. One thing I'm noticing is that the colors are a little bit noisy, probably a little bit noisier than I would like. I'll jump into our particles here. And 2 things that are driving this. One, we're actually just using this procedural terrain map, which is our default velocity input, but not our real velocity input, to remap this color. So I'm going to drop the real velocity in there for starters, since that will certainly help. And then, that's already helping. And then I'm just going to use this blur to potentially blur things a little bit more, or even parameterize our blur. Palette remap blur. Cool. And then if we increase that a little bit, yeah, a little bit more consistency in the color. Still want to make sure there's a little bit of noise, and there certainly is, as we can see here. But I'll probably, yeah. So you can see now that, especially with the pre-shrink, our colorings are becoming much more consistent. So I'll leave that for now. That's looking pretty good. I think the rest in here is probably fine. Don't need to make any more changes. So yeah, I think this is probably the last of the tweaking we'll do for the inputs. Our next step is going to be to start to add a little bit of complexity to this through another use of the mat, actually. So let's get going on that. So we were just using the mat top to help process our fluid. One of the things, I guess if we pop back up, it's a bit easier to see. One of the things that we can do to add a little bit of more interest and complexity here is defining some sort of texture that's going to mix two of our velocity maps in a UV delineated way, meaning that pixels on the left of the screen may be from one velocity map, pixels on the other part of the screen may be from another velocity map. This is different from blending via the switch or across, because here, even though we're halfway between input 1 and input 2, and we have blending on, this is equally blending every single pixel across the entire screen from those two velocity maps, right? So it's the same as just averaging those two textures. That's not what I'm interested in. While it does provide some interesting effects, I want something that's a little bit more, that contributes a little bit more to the form of the piece. And that's why I like the matte top a lot, because the matte top does exactly what I just said, which is define a source of a pixel in one location differently from the source of a pixel in another location based off of some input texture map. So let's give ourselves some more space. I'm going to use another select top, grab that switch, wire this in here, and input maps. Need a point file, and yeah, just some last organization before we get going. Particle system. Alright, cool. Like I said, I like to try to keep things organized. This helps me. It's a little frustrating that these are opaque. You can turn that off. I go back and forth on whether I like it opaque or not. I'm going to leave them opaque for now. But now we have our 3 blocks. We have no connectors in between because of our select tops, which I think makes things look pretty nice and clean. So now what we need to do is figure out how do we use a matte top to add some visual complexity here. Well, it has to come from, or it has to be added here in our velocity in map workflow. You know, I'll try it because it makes it easier to see the visuals behind as we're working. So I'll leave for now. Alright. So let's add a matte in here. Very good. Let's get another select. And so this is going to be our main vel, and this will be our matte vel, and then we're going to need one more, which is to be our actual matte texture. Our main vel, we have our matte vel, and we have our matte texture, which I'm going to also use a select for now. Actually, I'll use a rectangle for now again. That's kind of cool. Alright, so let's see what's going on here. Well, these are both the same, so nothing is going on. Let's change our velocity input to 0, and then our matte vel. Okay, so how about maybe we'll do main switch, and then we'll do matte switch. And these, that's going to require another parameter. Index, velocity input, main index, and then I'm just going to call this matte index. And then this is going to be index 2. So now we can control our two different switches, which is great. Cool. And we do have our matte, which is right now just a rectangle. And actually, let's go one further and say, let's do an in. Alright, so this is going to be our matte input, matte in. Alright. So now, let's wire this up and see what happens. If we change our matte index to a 2, but our main velocity is still 0, we can see that, whoops, haha, there we go. And now that should work. So we can see here that it is working. For the most part, our velocity map is a function of these two things. Let's try something a little bit more dark. Interesting. Alright, what's going on there? Alright, and we can see that it is still working here, so that's good to know. And now what have I done? That's interesting. Okay. So our remap was getting a little bit messed up there because of our matte, which is fine. You know, sometimes adding parameters will cause some different things to happen. And we're seeing some tearing. That's kind of fine, I think. You can always go fix that if you really want to. Alright, sorry about that. I lost my train of thought. So, couple things that we have going on here. One, the breaks that you're noticing here, that's just because I had to set just a little bit over 2, so if we just set that to 2 exactly, then our breaks go away. You will also notice that there's not like a ton of, like, we're not seeing any impact from changing this main index here. The reason we're not seeing any impact is because all of this is getting scaled when we're sampling from our texture, and so basically our rectangle is just too big. So a few things, let's make it 1024 by 1024 and also 32-bit float. And then we'll get the size down to something like this maybe, and we'll see what happens. And it can be sometimes easier if we add a constant and we make it 0, and we'll add this as our matte velocity so that we can see what's happening a bit better. Alright, so now we can see that our rectangle is indeed working, and that's good. So then if we go down and reconnect this matte velocity, get rid of the constant, we will see, and I'm just going to do this to our, we will see that things are working as we want them to. And if I make this rectangle a bit wider, maybe just a little bit taller, we can see that we do have some changes in our velocity based off of our XY direction. And then we can see the change in our various inputs, although I guess these are pretty similar at the moment. Changing our inputs will affect different parts of our region. And let's get this down again a little bit more. I think this should be a little bit more clear as far as what's going on. So you kind of see the outline of the rectangle here, and actually if we either increase the softness, or better yet, if we just drop the alpha, then you can kind of see the impact this is having when we either turn on the matte or turn off the matte. And then if we change these, we'll see that this is changing just stuff outside of our rectangle, and then this index is going to change just what's going on inside of our rectangle. So rectangle itself can be, or any geometry, it can be a circle, whatever. Instance something, render it, use that for the matte. All very possible. Something else that you could do, possibly, is use a select, grab anything really, we can just grab this, use a threshold, kind of figure out how you want this threshold set up, maybe something like that. And then if we disconnect this, we will see that our matte now, which is much harder to see with this, maybe if I do that, yeah, we can see that our matte now is actually dynamically updating. So our velocity field is being mixed off of this terrain map. But it could also be this. You could even use the actual output itself, a bit of a feedback. Now, if you are doing this, it's generally going to be best to drop in a feedback, and then this. Drop in a feedback, and then you're gonna have to just like play around with the thresholds and stuff to get things dialed in. You could also do things like, oops, I guess this needs to pulse. You can also do things like blurring this afterwards. For example, there's a decent bit that you can do. Now, yeah, just remember it's all in a feedback loop. A decent bit that you can do to just play around with this. I find personally that a threshold on the output is an interesting way to do it, but a lot of times it'll be a little bit too detailed. So I will do something like a pretty strong blur maybe before I do my threshold, and then soften it just a little bit, something like this. Something like this. And there we go. There's our circular reference. Because I forgot to put a feedback in. And I'm going to put the feedback after the blur, so that we don't have that growing issue as we did before. So, classic. And yeah, so we'll go back to the rectangle. Get rid of these for now. And yes, so there you go. The map being one way to deal with this. Cool. So that's great. What is our last step? Our last step is to add some interactivity. So this is going to be pretty simple. I'm going to do two ways that we can do this. One is going to be using a Kinect depth, so there's me. Another will be using a Kinect chop. So let's First, since we've been working with the mat already, you can probably see where I'm going with this. Now, if you just take a Kinect, just do a threshold, do greater, and then maybe we can just like blur this. Actually, maybe I want to do that first. So there are ways with some better chroma keying that you could definitely improve this a little bit. I'm not gonna do everything on getting this Kinect working. If people are interested, I can do another tutorial that'll focus specifically on Kinect and how to work with it. For now, I'm just going to fine-tune this a little bit more than it is now. And then I'm just going to get rid of these plants behind me with a crop. So this is all going to be pretty specific to how you guys have your Kinect set up. Although you could do this with a webcam as well if you don't have a Kinect. So actually I want this back to less. Alright, awesome. So now I have this kind of silhouetted cutout of myself moving, and I can actually just pipe that right into our mat. And then we will see that as I'm moving here, our velocity mat is updating, and if I, whoops, alright, if I stand, it'll be a little more obvious, but yeah, so this is one super cheap way to add some interactivity. You will probably need to do some adjustments if you're going to try and overlay this silhouette on top of the output. You'll probably need to do some aspect ratio adjustments, so just keep that in mind. But yes, you could also easily use a webcam here and all of this will still work. So that's one way to use a Kinect. The other way is to use our chop. Select, I'm just going to grab one channel. I'm just going to grab my hand, where is that? Hand RTY. So my hand goes up, my hand goes down, my hand goes up, my hand goes down. And actually, I'll help that with visual. So my hand goes up, my hand goes down. Cool, right? Very simple. And then all we need to do here is a very quick trail. So what I like to do is just kind of establish the range. So we're looking at something like, what is that? Negative, a little bit more than -1 to a little bit less than half. Let's say maybe minus 0.75 to 0.25. So then we'll just math this. Range minus 0.75 to 0.25 to 0 to 1. Now we see that, alright, cool. So we're basically now just moving from 0 to 1. Again, that range is going to be pretty dependent on you and where you guys are at. Cool. And there we go. Now we can see what's happening. So I really stretch just about 1 and down to 0. Cool. So last thing I'm going to do is just put a limit on here. We will clamp that 0 and 1. And then a null. And this will just And now you can obviously do this with all of your other channels. And I mean, from here it's pretty simple. You can just take it and map it to anything you like. I will just drag and drop it on our velocity main, let's say. And then what I'll do, if you're, we'll jump in, we'll look at our main switch. And what I'm going to do, since this is going from 0 to 1, is just scale this by the length of our main switch, which I believe you can do with num inputs, but maybe not, and I'll just do with a len. So now we're going from 0 to 1, and we are fully cycling through all of our different terrain maps. I'll throw a filter on here to reduce some jitter, make that 1/10 of a second. Generally, I find 1/10 of a second to be a pretty good filter width for stuff that you still want to have a visible reactive component to it. So you want to make sure that, like hand up, that our stuff's changing as my hand goes down. We want that connection to be apparent, but a little bit smoother. I think 0.1's pretty good. So, yeah, this is gonna be where we stop our terrain particle tutorial. I hope it gives everyone a decent framework to use, continue building more complicated stuff, and hopefully you guys have learned something about procedural terrain, particle systems, and I'll catch everyone next time. Before we leave, I just want to say thank you to all my Patreons, especially the premium subscribers who I show at the end of the videos. Like I said before, it really means a lot to me that everyone is supportive and just interested in this stuff as much as I am. So, thank you all, and I look forward to the next one of these.